So my name is Tawana Young, and I am an education consultant for Mind. Prior to that, I spent 16 years in education. 7 of that was as a curriculum director for Columbus City Schools. So like you, I've really been working hard on trying to figure out how to help support teachers and students in this making mathematics learning impactful, and that's what we've been doing here. So today you are joining us for a journey. We're going to take a journey. So I'm going to ask you to put on a learner hat and take on the role as a student, a learner, and I want you to really think about what is it in this lesson that's motivating you? What is it in this lesson that is causing you to think, causing you to make connections? Where are you engaged at? So I want you to think about that. But then I also want you to keep on your educator professional hat. I want you to think about what kind of impact could this have? So we're going to see 2 very different lessons. Let me get my actor gear on, okay? All right, welcome class. I'm so excited for our lesson today. We are continuing our lesson on volume of a cone. And you know that we have been working really hard on getting our formulas so that we can make sure that we're meeting the standards that we're trying to do. So we have all of these cones that we interact with in the world. And what we want to do is we want to figure out, how do we find the volume of these things? So to do that, we're going to watch a video. As you listen to the video, I want you to take notes as Professor Rhombus is teaching you how to find the volume of a cone, and then we're going to go over it. All right? Everybody has their worksheet and their pencil. You guys ready?
The height of our cone is 9 inches, and when we multiply 9 inches by the base, we get 9 inches times 9 pi square inches, which equals 81 pi cubic inches.
Who thinks they can tell me what the volume of a cone is? What's the formula for finding the volume of a cone? Right, perfect. Volume equals 1/3 pi times the radius squared times height. That is the formula, and so we're going to take that formula and we're actually going to engage in some practice. What is, if we look at our volume formula, we see that we're doing 1/3 pi times the radius squared times the height. Who can tell me what the radius is if our diameter is 8 inches? All right, so you guys, I feel really good, like you know what you're doing, right? And you can do some problems on your own. So now what I'm gonna do is I'm gonna give you some practice problems. I have pushed some problems out to your iPad. Think about the components that were in that lesson. We had technology, we had other kinds of things. I want you to think about where you had an opportunity to really explore and figure things out. On the back of your paper, you have 2 lines. In the top line, I want you to write 1 word that describes that lesson and hold it up. So make sure you write it big so I can see it. All right, so I see frustrating, I see okay, I see boring, process, procedural. All right, so those are all things that you experienced with that lesson.
The minute they did the traditional class, I felt that pit in my stomach. Totally, and I was just where you start to feel stupid. And even though, I knew I could do it, but it just took me back to high school.
So I'm going to take you to a different kind of lesson. And Dr. Peterson was talking about the concept car. So this is the concept of a lesson that we want to eventually get to, right? So again, put on your learner hat. Think about how you're engaged. Think about the opportunities you have to think and to grapple. All right, so get in my teacher mode for this one. All right, so welcome class. I am so excited, my Math Explorers, that we are continuing on our mission that we're doing. We have been taking a mission to Titan, Saturn's largest moon. And so we've been doing all kinds of really cool things. You have been building this rover, which is really cool. So you have learned all about the area of a circle. You learned all about the volume of a cylinder. We use that to figure out how much air we're going to put in the tires. Last week, we talked about a rain catcher. So what you have are some shapes on your table. And what I want you to do is I want you to see if you can figure out how to make the shapes that are on your table. So work with your partner, and there's a couple. So if you make one, then try to make another one, all right? So now with everything that you've learned, I want us to try to make a shape together. So I'm gonna pick a shape. I think I'm gonna pick this shape. All right, everybody see my shape that I have here? Who could tell me what I have? A cone. What is one thing you are gonna change, you're gonna tell me to change on this to make my cube into a cone? What I want you to do is use these pieces and prove how a twice ramped shape affects the whole volume. Look, I just happen to have some rice. And I have a cylinder and I have a cone. So come on over here. I'm gonna give these to you. If it's true, because we saw it with the cube, that a twice ramped shape is 1/3, how many times should he be able to actually, what is the relationship here? 3. So you should be able to fill this up 3 times for that. Do you guys think he'll be able to do it? Yeah. Let's see. Three. Yay! All right. So what we're going to do is this. Right now they have a circle, right? What dimension is my circle?
2.
2. We need a 3-dimensional shape. So if they make a 3-dimensional shape here, what should it be? Cylinder. So make a cylinder. If we ramp it twice, what's it look like? We got a cone and we have a pyramid. Do you have a cone and a pyramid? Yes. Now, make your full volume. So we learned the formula for volume of the cylinder last week. Volume equals pi times the radius squared times height. Think about what you know. How can we derive the formula for volume of a cone based on what we know? One-third times pi times the radius squared times height. So now what you do is you understand why this formula works. Now, I want you to think about that lesson. You had the lesson earlier, and then you had this lesson. I want you to think about the opportunities that you had to think, the opportunities you had to grapple, the opportunities you had to explore. And where was the accountability? I want you to write the one word that describes this lesson for you, and I want you to hold it up. All right, so I've got engaging, I've got relevant, proof, challenging, active, exploration, aha. Kids look at math as something where you do problem solving instead of something that solves problems. We saw how relevant those shapes were when we looked at the real world things, how relevant that is in our everyday lives, and kids don't see that. They see this. And so when you give them opportunities and activities that let them breathe in them and let them learn in them, that changes the game.
And then when we did the other lesson that opened up, it was like I saw all these generalities of what happened with the solids, and it was very exciting. And I'd never, those big ideas, I created those today based on that lesson.